Okay, hello and good morning. Let's talk about the bell work here. This right here is adding fractions or rational numbers here. And you need a least common denominator whenever you add or subtract. So let's take a look here. This one right here, what I would do is put a 1 under here first. And then your least common denominator here is going to be y squared. So you want to multiply this one by y squared, top and bottom. And when you do, you're going to get 14y squared plus 10 all over y squared. And that's about all you can do. You could factor out a 2, but it's not going to help you. So that should be your answer right there. You can't reduce, okay, unless you can factor out. All right, let's go on. This one right here, in order to factor it, or find your least common denominator, you have to factor this. So you got to take a 3 out, and you're going to be left with a minus 9, or a squared minus 9. Okay, but this is the difference of two squares. So that's going to further factor as a plus 3 and a minus 3. So all of this factors to this. Okay, now this one, you got to take a 3 out, and you're left with a plus 3. Now, to get your least common denominator, you can see they both have a 3. So 3 is part of your denominator. This one has an a plus 3, and so does this one, so you're going to do an a plus 3. But this one has an a minus 3, but this one doesn't. So a minus 3 is going to be part of your denominator, but in order to get that, you got to multiply top and bottom by a minus 3 here. And so what you're going to get is a negative a, okay, plus, now you're going to distribute the 1, which really doesn't change anything. 1 times a is a, and then 1 times negative 3 is negative 3. So now that you have your same denominator, these cancel, and you're just left with negative 3 over your least common denominator, which is all of that. And actually, you can reduce to 3. So let me write that down. So 3, a plus 3, a minus 3, and then the 3's cancel. So your answer will be negative 1 over a plus and a minus. And that's your answer right there. All right, now let's get off of adding and subtracting rational numbers. Let's talk about complex fractions. So copy this down right here. All right, a complex fraction is a fraction over a fraction. So all you do is rewrite it. So you're going to say x over 3 divided by, that's what that line means, divided by y over 3. Remember, keep, change, flip. So you're going to keep this, change that, and flip this. So the 3's cancel, and you get x over y, and you're done. And that's how you do it. Nothing to it but to do it. All right, let's go on. This one right here, you're going to rewrite it. So you're going to put 1 plus 1 over x divided by all of this. 1 minus 1 over x. Now, before you can flip it and change it, you got to get your least common denominator. So put a 1 under here. Your least common denominator is x, so you're going to multiply by x. So you're going to get x plus 1 over your least common denominator divided by, over here, you got to find your least common denominator, which is x. So you're going to multiply by x, so you're going to get x minus 1 over x. And now that you have it as a fraction divided by a fraction, now you can go ahead and flip the second one. So you're going to get x plus 1 over x times x over x minus 1. And then let's use a dot here for the times so we don't make it look like an x. This cancels, so your final answer will be x plus 1 over x minus 1. Your work for today is right here, okay, page 419. If you get stuck, make sure you ask for help. Let's turn our attention now to geometry. Okay, copy down everything you see right there. All right, let's talk about this. All right, now look, 3, 4, 5, right triangle. That is a classic right triangle, okay? In other words, if I do leg, this is my short leg, this is my long leg, and this is the hypotenuse. So if I do a squared plus b squared equals c squared, it does work. This is 9, this is 16, and this is 25, and you get 25 equals 25. Now we're going to talk about that in a minute, but this is a classic right triangle. So I want you to do it all three ways using the sine, the cosine, and the tangent. Well, put your finger here. So sine of angle x is going to be opposite over hypotenuse. So it's 3 over 5. And we'll work it in a minute. This one right here, the cosine of angle x, is adjacent over hypotenuse, so that's 4 over 5. And the tangent of angle x is equal to opposite over adjacent, so that would be 3 over 4. Now all of these should be the same because it's a right triangle, so let's check it. This one right here, you're going to divide by the word sine, and it's going to become the inverse. So clear your calculator out, take 3 divided by 5, or however you do it on your calculator, hit shift, and then sine. I get 36.9. Now all of these should be 36.9. So let's try the next one. This one you're going to divide by the word cosine, it becomes the arc cosine. So we want to do clear, 4 divided by 5, press equals and hit shift, and then press cosine, and you get the same thing. So all of these should work because it is a right triangle. All right? Now let's talk about something. Yesterday I gave you one, and I don't remember the numbers on it, but I think I put a 7 here and a 5 here. And you know that the hypotenuse is supposed to be the biggest one, okay? And I think I gave you another number here. So there were two problems with this one. Inherently flawed, we talked about it, but there's two things wrong with it. Number one, the hypotenuse should have been the 7. And number two, it has to be equal. The numbers have to work. So if I randomly put numbers in there, it probably will not be a right triangle. Okay, remember trig only works on a right triangle. So again, there's two flaws. Number one, I put my hypotenuse as a side, and that's wrong. The hypotenuse should be the longest. And number two, it has to satisfy Pythagorean's equation, or it's not a right triangle. So there were two things wrong with that problem I gave you yesterday. All right, let's go on. On the EOC on May 25th, and I want you to write that down, and those of you at home write it down. May 25th and May 26th is your exam. Your final EOC. Apparently we're not going to have a third practice. This will be it. So that's your geometry EOC. Now, on that EOC, and again, make sure you write down these dates, you have to know how to extract roots. Now I can use a calculator. Watch. I can take the square root of 20, so 20 shift square root and then times 5. I can do that all day. That's 22.4, okay? But when they say extract perfect roots, here's how you do it. You break it down with 2s, 3s, 5s, 7s, all prime numbers. 1 is not a prime number. So you're going to do 2 times 10 and then 2 times 5. All of this is equal to 20, but this is 2 of a kind. 2 of a kind makes a perfect square. So 5 square root of 20 is really 5, and then 4 times 5. 4 times 5 is 20. The square root of 4 is 2, so you're going to take a 2 out. That's called extracting a perfect root. And then 5 times 2 is 10. So it's going to be 10 square root of 5. Now if you want to check it, it should be the same thing as what I had before. So I'm going to press 5, shift, square root, times 10. And this lets you know if you're doing it right. And it's exactly the same thing I had before. I'm going to do one more. 2 square root of 32. Start off with 2's. So 2 times 16. Bam! 16 is a perfect square. 4 times 4. So I'm going to rewrite this as 2, and I'm going to slide this up so you can see it, 2 square root of 2 times 16. But the square root of 16 is 4. 4 times 2, you got to multiply these. So it's going to be 8 square root of 2, and that's how you do it on the EOC. Make sure you know how to do that, because the honors kids know how to do that, and I want you to be able to compete with them. All right, put away your bell work. We talked about the error yesterday. Now we're going on to a new section. Okay, we're going to skip 8.4. Copy this down. This is actually 8.5, and this is our last section. So next week you will have a test. I'm not sure what day yet. If I had to guess, I'm going to say Tuesday or Wednesday. Okay, probably more Wednesday. All right, now let's take a look at this. Here it says the angle of elevation is equal to the angle of depression. Let's talk about that. All right, let's say you're standing up, and I can't draw very well, so you're going to have to bear with me. So if you look straight ahead, that's called your line of sight. Line of sight. Copy that down. Okay? Straight ahead is your line of sight. Now let's say you see a little ant down here, and I'm going to make it kind of big. So here's the ant down there, okay? And you look down. That's called an angle of depression. Angle of depression. Okay? And here's the ground. And what you need to know is, here's your right triangle right here. Because we're looking for trig in a right triangle. The angle of depression is the same as the angle of elevation, because this is parallel, and these are called alternating interior. So the angle of depression is the same as the angle of elevation. So if they tell you the angle of depression is 30 degrees, then the angle of elevation is also 30 degrees, and then you can use trig to find whatever you want. Like if you're looking for how tall the person is, and they tell you the distance from the guy's feet to the ant, the base is what they'd use. Let's say it's 15 feet. Then you can do opposite over adjacent, which is tangent. So you could say the tangent of 30 degrees is equal to opposite over adjacent. You can multiply by 15 and figure out how tall that person is. All right, so today we're doing word problems. Now, you're not going to be Mr. Genius on all of these, okay? And this is the first time you're seeing any of this. And this is dealing with trigonometry. So you got 10 problems here, okay? Now, I'm going to show you some of these before I give you your worksheet. So look up here and listen. Number 1, the angle of elevation to the top of a building. So here's a building. So number 1, and the angle of elevation. So you got the ground here. There's your right triangle, and the angle of elevation is going to be 60 degrees right here. And the angle of elevation to the top of a building, that is a distance of 50 meters from the foot. So 50 meters from the foot is here, from here to here. So that's 50 meters. And they're looking for the height of the building. So on this one, you would stand here, and it would be opposite over adjacent. So that would be the tangent. Okay? All right, let's go on. I'm going to do one more with you. Okay? The idea is you're trying to make a right triangle. Here's another one. Number 2. A ladder is placed against a wall. So here's your wall, and then here's your ladder. So here's your right triangle right here. The ladder and the wall make a right triangle. Now look at what it says. Reaches the top of a wall at a height of 6 meters, and the ladder is inclined at 60 degrees. So put 60 degrees here. That's your elevation there. Find how far the ladder is from the foot of the wall. So here's the foot. The foot is the bottom, so they're looking for that, and it's up 6 meters. So on this one, it looks like the tangent again. You're going to stand here. It's going to be opposite over adjacent. So you're going to have to try your best and figure out some kind of right triangle. I'll just do one more with you. The string of a kite is 100 meters. Well, here is your triangle, your right triangle. Here's your kite way up here. Okay? I'm sure all of you have flown a kite. So the string is from here to here, so that's 100. Okay? And the angle with the horizon is 60 degrees. All right, so we want to do 60 degrees here. It looks like they keep using 60 for some reason. Find the height of the kite. The height of the kite is straight down. So on this one, it looks like opposite over hypotenuse. That would be sine. So that would be the sine of 60 degrees is equal to opposite over hypotenuse. Now I put the answers here. Like this one, you got to convert. So watch how I do it. And I showed you this already. Press 3, shift, square root, and then times 50. So this one really is 86.6. So if you get 86.6, then you know you set it up correctly. All right? That's what we're doing today, and I'll help you as you get stuck. Good luck. Remember, you must try to make a right triangle. Okay? Here it is.